All right, so this video is identifying special angles measured in radians. So we study special angles 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And their multiples. So why do we like these angles? Well, the reason is that we can, if we have triangles that have these angles, right triangles that have these angles, we can actually find the length of the sides of those right triangles using the Pythagorean theorem. So we sort of stick with those a lot, really, even though in applications you might pretty likely you wouldn't get 30 degrees, but so you might not get that in applications, but it's a good way to learn trigonometry. Now, we said that if we go all the way around the circle, it's 360 degrees, and then half of that would be 180, half of that again is 90. Now, if I take 90 and I divide that in 3 pieces, I'm going to get 30 degrees. So now let me go ahead and actually put a circle here. Sometimes it's, well, okay, here's my circle, I guess. So I'm writing this as 30 degrees right there. And I'll just put that right up here, 30. So 30 is half, or is 1/3 of 90. And then if I multiply 30 by 2, I get 60 degrees. And I'm going to continue doing this. I'm going to take each of these right angles and break this into 3 pieces. And I'm just going to add here and do really find multiples of 30. 30, 60, 90. 3 times 4 is 12, 120, 150, 180, 210. So I'm multiplying 3 by different integers and getting the multiples of 30. And so let me also make sure I make this clear, is that on these on the x and y axis I get 90 degrees, 180, 270, 360. Those are important. Okay, so this gives us multiples of 30 degrees and also multiples of 60 degrees. 60 times 2 is 120, times 3 is 180, times 4, 240, 300. I'm sort of debating whether I should put this all in the same picture, and I guess maybe I won't. I'm going to also write 45-degree angles here, but I'll use a different circle. Half of 90 is 45 degrees. So then I can do the same thing where I find multiples of 45. 45 times 2 is 90. Another 45 makes 135 degrees. Another 45 makes 180 degrees. Then 235 degrees, 270 degrees, 315 degrees, 360 degrees. I'm not really that big on radians anyway, so a lot of people invest time and effort and brain power into learning the circle in terms of degrees, and that's good too. But we're going to do radians. Okay, so. Let's then do that then, looking at the circle in terms of radians. Okay, so in terms of radians, I'm going to remind ourselves that 1 surround is 2 pi, half of that is pi, and then half of that again is pi over 2. Now, if you take pi over 2 and divide it by 3, you're multiplying by 1/3, and you're going to get pi over 6. Okay, so I'm going to find multiples of pi over 6, and when I do that, I'm going to have to deal with fractions. Okay, so here I have 1/6 and I have 2/6. Well, 2/6 is pi over 3. 3/6, 4/6, which is 2/3 pi, and then 5/6 pi, 6/6, 7/6, 8/6, which is 4/3 pi, 9/6, which is 3/2 pi, 10/6, which is 5/3 pi, and then 11/6 pi, and then 12/6. It's just fractions. Now notice, since pi over 6 goes into pi over 3, these also give us multiples of pi over 3. So 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. So I feel like I'm going to make a mess of this if I write down all these denominators as 6, but it's 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, etc. It's just multiples of 1/6, and you can count that out. And then we can do the same sort of thing with pi over 4. So pi over 2 is up here, half of that is pi over 4. And then we add 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, which is 3/2, and then 7/4 pi. Okay, now if we compare this circle with the circle that was done in degrees, we see that pi over 4 is equal to 45 degrees. And if we go up here, we're going to get pi over 6. If you look at the other one above, that's 30 degrees. And then pi over 3 is equal to 60 degrees by comparing them. You can also use a conversion of multiplying this by pi over 6 by 180 over pi to get that. But it's easy just to compare those two circles. Pi over 2 is 90 degrees. Pi is equal to 180 degrees. I mean, you can do more of those. For each of these, you could try to fill in this. Okay.